Hi, this video is about aqueous solutions. We're also going to be talking about reactions that happen in aqueous solution. I like to abbreviate solution S-O-L-N. So if you ever see that, that just means solution. All right, so let's go back and review a few vocabulary words. A solution is a homogeneous mixture. That means it's uniform throughout of two or more substances. Now, the solute is what is present in the least amount, and the solvent is what's present in the most amount, and an aqueous solution is when our solvent is water. All right, well, we have two categories of those solutes that are being dissolved in water. They're electrolytes and non-electrolytes, and I want you to know these definitions. Okay, so an electrolyte is a substance that when it dissolves in water, it will conduct electricity. And a non-electrolyte is just the opposite, and as the name implies, when it dissolves in water, it does not conduct electricity. Well, what causes some things to conduct and some things to not conduct? Well, electrolytes, things that do conduct electricity, are solutions that contain ions. They have charges. That's why they're conducting electricity. And so, as the name implies, ions, ionic compounds, when you dissolve them in water, will be electrolytes. And then there are two classes of electrolytes. We have strong electrolytes and we have weak electrolytes. Strong electrolytes would have a lot of ions in solution. And so they will conduct an electrical current. And weak electrolytes would have, compared to the strong electrolytes, few ions in solution. So, what is a strong electrolyte? What causes a lot of ions in solution? Well, soluble ionic compounds. Let's review. Just like in naming an ionic compound, so this should be review for you, an ionic compound is something that has a metal and a nonmetal. And remember, the metal loses its electron or electrons to become positively charged, and so that forms our cation, or our positive charge, and then something has to take those electrons, and that's a nonmetal that takes our electrons and then has the negative charge. So that's our anion. So let's look at some examples. So if we have potassium chloride, all right, if it's a solid, all right, it will not conduct electricity. So don't let that trick you up. If it is a solid, potassium chloride, even though it's an ionic compound, it will not conduct electricity. Well, if we heat it up and we melt it a little bit, and they'll tell you that it's molten, well, then we do have ions, and it will conduct electricity. So there would be an electrolyte. The solid potassium chloride is not an electrolyte. The molten potassium chloride is an electrolyte. Now, what are we calling these strong electrolytes? We said they're soluble ionic compounds. So if they showed you KCl and then it had an AQ after it, which means it's an aqueous solution, that would be a strong electrolyte. What's really in solution is potassium ions and chloride ions. And so the KCl aqueous solution in solution is just ions, so it's a strong electrolyte. If it's solid potassium chloride, it's not dissolved in water, so it's not a solution, it's not aqueous, it is not an electrolyte. Sometimes they like to trick you up on that. Let's look at one more ionic compound. Let's look at, let's do calcium. Let's see, nitrate. Oh, nitrates are soluble. All right, calcium nitrate. It's an ionic compound, and if it had this AQ after it, it's in solution, it's in water, it's soluble, and what do we actually have in solution? We actually have the calcium plus 2 ions, and then we've got those nitrate ions in solution. So this would be a strong electrolyte. It has ions in solution. Well, there's one other thing that can be a strong electrolyte, and they are strong acids. Now, there are 7 strong acids, and let's go ahead here and get them written down. They're hydrochloric acid, HCl, hydroiodic acid, HI, hydrobromic acid, HBr. Those should be easier to remember. They're just those halogens with our hydrogen out front. Remember, we defined an acid as a proton donor. So it has that H out front. Nitric acid, HNO3, sulfuric acid, H2SO4, chloric acid, HClO3, and perchloric acid, HClO4. Now, where are the ions coming from? Strong acids pop off their proton. So hydrochloric acid, if it's set a solution of hydrochloric acid, so AQ, has an H plus and a Cl minus in solution. It pops off the H plus. These strong acids do this in solution. So nitric acid, strong electrolyte. It has the proton off and then the nitrate ion, and so it's a strong electrolyte. Okay, strong electrolytes, soluble ionic compounds, so they're aqueous. And strong acids, and there are 7 of them, and they completely dissociate. They completely come apart in water, which causes them to form the H plus ion and then whatever anion is with it. Okay, now there are some things that do conduct an electrical current, but they're weak electrolytes. They don't have nearly the amount of ions and when they're put in solution, and that is weak acids. So that would be all the other acids, all right? Anything else like acetic acid. Now, is this an electrolyte? Yes, it is, but it's not a strong electrolyte. It's a weak electrolyte. So we're going to do we're going to do a lab on this, and you'll see that acetic acid doesn't make the light bulb shine quite as brightly, so it's not as good of a conductor of electricity as, say, a strong acid. Why that is and this would be something for a higher level chemistry class, but why acetic acid and these other weak acids, any other acid that was not on that list, and we could just keep going here, like phosphoric acid, hydrofluoric acid, why that is only a few of the molecules, like 5% or less of them in solution, actually lose their proton. So most of that acid stays together, and like a small percentage of them will ionize. That's why they're weak electrolytes. So we could say a few percent, a low percentage of them dissociate. And again, the way they dissociate is the same way as a strong acid dissociates, which is having that H plus or the proton come off. All right, non-electrolytes do not conduct electricity. So what is left? Well, it's molecular compounds. And we learned those when we were naming. They're all nonmetals. Remember, we used the prefixes when we did that. And they do not conduct electricity at all. What does that mean? Well, when they're in solution, they don't ionize. They don't form ions at all. So, molecular compounds. So, let's think of an example of that. Well, let's see. C6H12O6. That would be, you should have learned that back in biology class. If we had an aqueous solution of that, there's no metal there. That would be a non-electrolyte. Now, this is an alcohol. This is actually called methanol. And again, no metal here, so non-electrolyte, no ions would be produced in solution. And so you just look at the front end. If there's no metal, unless it's that ammonium ion, then you'll know that it is a non-electrolyte. Okay, I forgot to talk about weak bases, and really the only one I want you to know right now is ammonia, NH3. That is the only weak base that we really need to know at this point, and it is a weak electrolyte, like those weak acids. It actually does not donate a proton. A base will accept a proton, but that's for our acid-base chapter later. So, weak electrolytes, just a few of the percentages of the molecules in solution will dissociate. Weak acids and our weak base that we need to know, which is ammonia, NH3. And then non-electrolytes are molecular compounds. They don't form any ions in solution, and they do not produce an electric current. Alrighty, that's it.